All right. So, if you were around for the end of the last class I was teaching in here, you might have heard that I had sort of a specific amount of content that I wanted to cover this week. And I think I've worked it out such that I can cover all of that content today, which means that you then don't have to come in on Friday. So that's what we're aiming for. I'm going to try and make it to the end of our slides, and so far I'm 2 for 2. So theoretically we should be done today, and then we can pick up the rest of this chapter after reading week, which would be kind of nice. So starting with our chapter 7 introduction here, we always start with a definition. And memory is going to be another one of those topics where things are fairly general and vague. So we can talk about memory as referring to either the structures or the processes that are involved in the storage and retrieval of information. So there's a lot of fuzziness here. So some people care a lot about which physical parts of the brain, which structures within the brain are important. And a lot of people care about just the process that's going on. And some people care about both. So we're actually going to be looking at different people's perspectives on memory as time goes on. But in general, memory could be used to refer to either of those or both of those all in combination. And of course, we can also talk about a memory, which would be a recollection of a single event. So lots of terms that can be a little bit overlapping here. But when we're looking at memory and how we can describe memory, we can ask 3 general questions. There's probably a couple more we could include, but these fit nicely with our 3 types or 3 stages of memory formation. So the first question is, how does information get into memory? How do we take things from our environment and put them into some kind of meaningful code that our brains can store for later? Next, how is that information maintained in our memory? How do we hold on to it for a certain amount of time? And then the last part is, how can we pull information back out of our memory in order to use it? And so each of these questions corresponds to the 3 sort of sections of memory. So we can talk about encoding, the process of how we initially form and turn information into something that we can learn and store for later. Storage is our process of maintaining information over time, and sometimes we can maintain it for a short period of time, sometimes we maintain it for long periods of time. So we have different kinds of storage that we can talk about. And the last step is retrieval. So how do we pull information out of storage in order to do something with it later on? So theoretically, you'd be remembering a particular event and then deciding to do something with that memory. So these are our 3 processes. But before we break it down into each of these 3 stages, we're actually going to take a little bit of a detour. And we're going to talk about how we talk about memory. So what kind of language do we use when we're discussing memory? And also, how does the language that we use shape our perception of the process? So most of the language that we use when talking about memory revolves around a search metaphor. So we describe the processes involved in memory using terms and phrases that relate to searching in either a physical or virtual space. So the idea of sort of looking for a memory or retrieving a memory as though it's a single item or unit that we can kind of move and place into storage and retrieve later on. So maybe we're reliving a particular moment, we're going to experience that unit of memory, or we're bringing something to the front of our mind into our active consciousness, or finding a solution for a particular problem using our existing knowledge. So lots of searching type words. And we've also found that as technology has been evolving, a lot of the terms that we're using to describe the memory process have kind of lined up with our computer processes. So when we talk about encoding and storage and retrieval, this runs in parallel with, say, the process of using a computer. Encoding would be saving a file to your hard drive where it is stored for long-term storage. And when we retrieve it, when we open that file in the future, we're retrieving the same file or the same information that was there when we stored it away to begin with. And this way of talking about memory and these sort of terms that we use kind of lead us to this assumption that memories are like single standalone units that can then be put into storage and retrieved, and they're unchanging and static. And of course, we're going to talk about why that isn't accurate. So our search metaphor kind of lines up with, if you've seen the movie Inside Out, where they're going and looking at memories, and each memory is contained in a glass ball in a specific spot on the shelves, and you can kind of go to that location and find that memory and everything is fine. That's sort of what goes along with this, and it isn't quite accurate. And we're going to look at bits of information and situations that show us some of the inaccuracies of that framing. So the first situation, a lot of studies of memory will ask you to draw something that's fairly familiar. And one of the big studies is asking people to draw a penny. And from these images, you can probably tell that they were asked to draw a US penny. So this is a study done in the US. But if we were doing something similar in Canada, I guess we can't use pennies anymore, but maybe we could ask about dimes or something like that. But you've probably seen a US penny at some point in your lives. And these pennies have been the exact same for over a century, at least on the heads side of the penny. So maybe you can kind of fill in the gaps here. But if researchers asked a whole bunch of people to draw the heads side of a penny, they would get a variety of different images. And yeah, some of it is down to artistic ability. Not everyone is great at drawing. But if we ignore sort of quality of drawing, we can see that there's a lot of variability here. In between, so there's different words or the same words in different places. Some people have some information and others don't have that information. And even with the heads, that we know there is a head here, they're in different orientations. Some of them are face on, some of them are facing left, some facing right. There's a lot of differences here. And so none of these are exactly the same. And looking at them, I don't know if we could tell which one is accurate. Even if we were looking at Canadian change, I don't think I'd be able to tell which one is accurate. So if we wanted to look at the data from this study, we can look at this sort of amalgamation of different elements that they were looking for. And so they're not even caring about the orientation of the head here. They're just looking at particular items and whether they're present or not. So things like the phrase "in God we trust," having a date that it was minted. And so the ones that are in green are things that are actually on that side of a penny, things that should be there. And things in red are things that were included but should not have been included. So things that aren't on that side of a penny. And if we look at the percent of participants who drew each of those elements, we see that people did fairly well with the "in God we trust" and the minting date. 70 and 50% of participants got those things that should have been drawn, which is great, but they didn't do very well with the phrase "liberty." So only 5% actually knew to include an element that should have been there. And that's even more impressive when we see that for the 3 elements that we're looking at that should not have been included, these were all included a lot more often than liberty. So saying 1 cent or 1 penny, the United States of America, or even their sort of Latin phrase, those were included quite a bit more often than liberty. So somehow people were remembering something that did not occur, the stuff in red, a lot more than one of the elements that should have occurred. So what's going on here? How are people recalling this information incorrectly? If we just use that sort of search metaphor that we've been talking about, we would think of people retrieving a particular image. Maybe you remember back to a penny that you have seen. So you could only look at pennies that exist. So how could you store the wrong image in your brain? What's going on there? So this search metaphor doesn't really work with some of the errors that we see in a lot of our different studies. So we remember something that never actually occurred. We're remembering parts of that coin that were never actually there. And so this is our first hint that that search metaphor isn't necessarily the most accurate way to conceptualize memory, because things aren't as static and sort of unchanging as we might envision them to be. So if searching isn't necessarily the best way to frame it, what is going on? What should we frame it as instead? And so we can use instead what's called a reconstruction metaphor. And this is the idea that we use memory to cobble together a useful response using both what we know and the information available to us at that time. So this is the idea that basically our brain is going to make a best guess based on information that we have available to us. So we don't necessarily pull a single unit of perfectly preserved memory to look at and evaluate. Instead, we'll start pulling together information from different sources to put together our best idea of what probably happened. So we would put together what should be on a penny based on some logic and maybe some remembering of pennies, but also, filling in some gaps using our own knowledge. And so we can talk about a really neat example that looks at this reconstruction process. And these are flashbulb memories. So if you've never heard of these before, flashbulb memories are thought to be a specific kind of memory that's remembered a lot more vividly with a lot more detail than other normal memories. And they're typically centered around very emotionally intense situations. So most of the ones that we have here, JFK's assassination or the Challenger explosion, September 11th, those are all events that were very intense. They would have been noticed by a lot of people, and people might remember exactly where they were when certain events happened. We run into an issue where as time goes on and as information becomes more available, we're having people exposed to information at different times in different ways. So instead of everyone gathered around the TV watching a news report on an event, we have phones in our pockets that can tell us when something happens. And maybe we see something days after everyone else did. So flashbulb memories are less of a sort of single unifying event and more of a blur across multiple things lately, which is one of the main reasons why we typically don't see a lot of modern flashbulb memories. I came to the realization in the last couple of years as I've been teaching that my students were no longer born necessarily before September 11th, let alone having memories of that event. So even though that is the most recent well-studied flashbulb memory, it's not necessarily recent in actual terms, because that's 20 years ago now. So we could think of things like maybe you remember exactly where you were when you saw the results of the most recent US election. Or for myself, one that works really well is the last day that I was on campus before the first COVID lockdown. And that's because we actually kept the department open specifically so that my office mate could defend her PhD before we went into lockdown, because they had no idea how they might do her defense completely online. Because we had no idea how to do it at the time. So we were in person on campus. Everything else was shut down except our department, and we had her defense spread out in the largest room we could find. And that is my memory of that day. But of course, as I've said, with these moments, that date might have been different for other people. And so we would have vivid memories of particular items if they have emotional significance to us. Okay, and so that's sort of a little bit of a tangent there. But if we focus in on the fact that most of the recent research that we can look at for good flashbulb memories would be September 11th. So that's what we're going to deal with, even though it isn't recent anymore. But if we look at these graphs here, this is from a particular study that basically had psychologists who noticed that, okay, flashbulb events tend to be things that are very emotionally charged, things that people know exactly where and when they were when something happened. So when September 11th happened, these researchers immediately knew that they wanted to do a long-term study to see how people's memories of that event changed over time. So they interviewed people days and weeks right after September 11th. They asked them where they were, what they were doing, what they remember, all of those different things. They had a set of questions. And then they had those same people come back a year later, and then 5 years later, and then 10 years later, and now 20 years later. And they could ask the same questions again and see how their responses change over time. And so from these graphs here, we're going to look at the bar graphs first. This is looking at Survey 2 and Survey 4. Survey 2 was the 1 year later. Survey 4 was 10 years later. And these are just compared to the baseline of their first survey in the same year. And then our y-axis is the number of participants who scored certain amounts. So along the bottom, we have the number of inconsistencies. Basically, how many errors did they make between the first time they were interviewed and the second time, or the third, or the fourth? So how many details of their story changed over time? And so we can see that some people had 0 changes. It was the same the first time as it was the second or the fourth time. But some people had as many as 5 different core details that changed in their recollections. And if we look between Survey 2 and Survey 4, so 1 year versus 10 years, that distribution of data is pretty much identical. In fact, there's no statistical difference in those data distributions. So most people have about 2 inconsistent details in their story, whether it's 1 year later or 10 years later. And we can look at that data a slightly different way. So on the side here with our line graphs, the one labeled A is looking at consistency. So instead of looking specifically at the number of errors, we're looking at how consistent are their stories. So if they reported 10 details and they got 6 of them right, then that would be a 60% consistency. And so this allows us to sort of compare between people. And this has sort of Survey 2, Survey 3, and 4. So 2 is still 1 year later, 4 is still 10 years later, and 3 was 5 years later, not quite in the middle. So we're looking there and we're saying, okay, 60% consistency and almost consistent in their inconsistencies across that period of time. So whether it's 1 year later or 5 years later or 10 years later, they're still only about 60% accurate to their first story. So a certain number of details have changed. About 40% of their details changed in between that first story and the subsequent stories. And we actually see a similar pattern if we look at their confidence. So on a scale of 1 to 5, how confident are they in the accuracy of their story? They are very confident, even though they are not very accurate. So we can see that these flashbulb memories tend to be very inaccurate, and they're consistently inaccurate. So after that first telling, stuff changes, and then it stays at that level of change. And people are very confident in their accuracy, even though they aren't accurate, which is kind of neat. So this is that first indicator that flashbulb memories aren't necessarily a special kind of memory. We frame them as something special and important, where having that emotional connection gives us that, yes, I remember exactly what I was doing, when I was doing it, and how I was doing it. But in fact, we're not that accurate. And from this, people have determined that flashbulb memories aren't really any different in terms of composition from normal memories. Just that they're linked to an event, a particular kind of event, but that doesn't necessarily make them special. And so what's going on here if we're seeing A, inaccuracies, and B, consistency in those inaccuracies? And we'll talk a little bit more about this later on, but the brief story is that each time we pull a memory from our storage, we have the potential to start filling in missing details with available information. So maybe the first time you remember it, it was fairly recent, so you remember a bunch of details. And you can kind of fill in some gaps because, well, it was this time of day, so I was probably doing this thing. Even if you may not have been doing that thing, but it's the right time of day, so you fill in that gap. The next time you recall that memory, maybe now you're not recalling the memory, but the story of what you were remembering. And you can remember those gaps that you filled in and you become more certain of how accurate they are because you keep recalling them. And so over time, we maintain that confidence even though it maybe isn't earned. And so we'll talk about that a little bit later on, but this ends up being very important for things like eyewitness statements. So at a trial, asking someone, oh, was this person in this place? Did you see this thing happen? Those memories are a lot more flexible than we would like to believe. And so that could be part of how we frame talking about memories as sort of static and unchangeable units. And maybe it's just, what we think is the case, but just something to keep in mind. So we come to our conclusion that, memories are often reconstructions based on information we have available to us. We're filling in those gaps, we're making a best guess, and a lot of the time we're going to end up to be fairly accurate. And that's because we like routines. I take the same route to campus every single day. So if you asked me where I was at a particular time, I might not know, but I could say, oh, well, my class starts at this time. I'm usually on campus by then. I was sitting in the parking lot because I'm always sitting in the parking lot. So it would be correct recall, but not because you remembered, but because you could make some logical jumps. And so sometimes we can lead to incorrect recall. So if we're presented with extra information, if we make illogical jumps, or especially if we're exposed to extra information that can bias what we remember, we can start seeing inaccuracies. So it's always good to keep that in mind. And so I always take this little detour at the beginning because this idea of memory being reconstructive instead of something that is static and sort of mobile is very important. And so this is going to be something that repeats and comes up throughout this chapter, but I wanted to get it out of the way at first. All right, next we are going to talk about encoding memory. So this is the first step of that memory chain we were talking about. So encoding and storage and retrieval. We're starting with encoding. So we always have our definition at the beginning. So encoding is the process of putting memory into some kind of usable code. If we think back to our chapter on sensation and perception, we talked about a process called transduction. So we took information from stimuli in our environment, our sensory receptors turned it into some kind of neural code that could then be sent to the brain and interpreted. Encoding is basically the same idea. And in fact, encoding is typically going to be using our sensory information. But this is how we initially learn information, how we bring things in from our environment in order to do something with it. And so you might see this framed as us needing to overcome the encoding problem before we can do anything with this information. And that basically means that we have to figure out how to take stuff from our environment, put it into a kind of usable code, and then bring it into our brains to put it somewhere. So we have to get it into a form that we can use before we can put it into storage. So a lot of people will frame it as this encoding problem, which makes it sound a lot more important and grandiose than it really is. But in fact, we're just looking at, okay, how do we get things from our environment and into our brains in a usable format? And the first thing we want to talk about here is our sensory memory. So sensory memory is a system that keeps information translated by our senses, stuff that our sensory receptors have picked up on. It keeps it briefly active in a relatively unaltered form. So this is basically the idea that information is coming in from our sensory receptors, and maybe we're not actively paying attention to it right now. But it's going to be available to us for more than just the split instant when it first arrives in our brain. There's a little bit of a buffer there. And so we're going to look at two distinct types of sensory memory. We can have different sensory memories, but these are the two that people have actually studied and the two that we know the most about. So these are the ones we talk about. But iconic memory is a visual form of sensory memory. We can talk about pieces of iconic information as icons, so things that we can see. So maybe you're walking down the hall and all of a sudden you stop and go, wait, what did that person's shirt just say? And so you can almost like replay it back in your mind where something has caught your attention and you can go back to, what did I just see? For echoic memory, this is our auditory form of sensory memory. We can call these bits of information echoes. So we're dealing with auditory information. I'm really bad for this one, but sometimes when you're talking to someone, they come up to you and start talking before you're paying attention. And you tell them, hold on, wait, what are you saying? You ask them to repeat themselves. But by the time they've recollected their thoughts and gotten ready to start the conversation again, you've been able to rewind in your mind and you know exactly what they were saying. You just needed the time to process it. So that's because we're capable of doing that because of our echoic memory. So these are just kind of like a little flash of what happened, a buffer holding that information briefly for a moment until we decide if we're going to use it or not. And so how do we actually measure these things? How do we process this ability of ours? And one of the best ways to do this is through this process depicted on this slide here. And so we're going to talk about it using visual information. You can also figure out a way to do this with auditory information. It's just not as clean. So we're sticking with the visual example. So here, step one is basically giving someone a fixation point. So you have a participant, they're sitting in front of a computer screen. You get them to stare at that cross so that you know that they're facing in the right direction and that they're paying attention. Once they've paid attention to that particular location, you would display your stimuli. So in this case, they're showing for just a fraction of a second, 1/20th of a second, they have 3 rows with 4 letters each. You could use numbers, you could use any kind of visual stimuli here, but we would flash this on the screen for just a fraction of a second, just long enough for it to register with our visual receptors, but not so long that we might have conscious awareness of what we just saw. So we would have to rely on our iconic store in order to be able to figure out what it is that we just saw. There's a couple of different ways we can ask about this information. The first is we stop after the display and immediately ask them what they saw. That would be called a full report, where you ask them, of all of the letters that you saw, which ones do you remember and where were they? We could also do something called a partial report, and this is when they introduce a tone. So a tone of different frequency. So maybe it's high pitch, medium pitch, or low pitch. And the idea is, say a high pitch tone, they're asking you to report the upper line. Low pitch tone is the bottom line, and the middle one's the middle. So you don't have to remember absolutely everything, you just have to remember a single line. And by having this tone, they ensure that you saw the whole display, but you don't know which part is important. So you can't start rehearsing what you saw or anything like that until you hear the tone. So they would delay when you hear the tone. So it might be 0.15 or 0.3 or 0.5 of a second, all the way up to a full second. And they can see how accurate are you based on how much of a delay were you given. And the idea is that the longer time, or the more time has passed, the less accurate your report will be, because that information will have faded from your visual stores. So your iconic stores would deteriorate over time. And so we can get a pretty accurate image of how accurate, or of how long you're able to hold that information in your iconic stores. And so typically we're good for a fraction of a second. If we do this and set this up with auditory stimuli, we're a lot accurate for a lot longer. With auditory stimuli, we could be sort of 1 to 2 seconds depending. So if it's sort of a second or two, then it's echoic. If it's fractions of a second, then that's more of our iconic restrictions. But it's just long enough for us to kind of be able to refresh or look back on what we just saw or heard and make use of that information if we deem it important. And I already mentioned that we are a lot better at those partial reports than we are at full reports, just because we don't have to remember as many things. So we're a lot more accurate there. And so in this process of encoding our memories, there's a lot of stuff that matters, that's important for knowing what makes it into our memory. So these things are how we overcome that encoding problem. And this is going to be a lot of familiar stuff. If we go back to the idea of attention and awareness, we have to pay attention to a stimulus in order to turn it into something that we can use later. So if you think about, just had a moment, if you think about watching that video about inattentional blindness, if we had just watched the first part of the video, we asked you to count how many passes there were. If someone asked you about that video, you'd talk about people passing basketballs. But because we then sort of rewound it and got you to watch it again and notice that there was an extra figure in there, that helped you go, okay, so there's more there to it. I saw it the first time but didn't realize I saw it. And now that I know that I saw it, now that I've seen it again, it has registered, I've paid attention to it, and now it's in my memory. But if you weren't aware of seeing it, even if your senses picked up on it, not having that awareness means that it wouldn't go into your memory. And so we have sort of this selection of what we pay attention to. And we can kind of tie that into that idea of our iconic and echoic stores. We can rewind and think back to stuff that we've just heard. So some people would call this the process of filtering. What information do we pay attention to? What is important enough to grab our attention? And how do we decide what we listen to or look at or whatever? And so there's two broad categories here. There are early selection models and late selection models, and all they do is disagree on where we put those filters. And of course, when we look at more modern research, we find that neither is fully correct. It's kind of an in-between, which basically says that we can move these filters back and forth depending on what information it is we're looking at, what kind of setup we have. So with this diagram here, we're looking at going from a stimulus from our environment over to some kind of behavioral response. So we start with our sensory detection. Is it something that we can hear, or is it something that we can see? Our early selection model people would say that as soon as you can detect it, that's when you would decide to pay attention or not. But our late selection model folks would say that, okay, well, what if we have to pay attention to the recognition or the meaning once we sort of assign meaning to something? So if you are walking through a crowd and you hear your name, that's going to draw your attention. And you can use your echoic stores to kind of rewind the conversation and hear what they were saying. So you can have that filter in place after you've recognized it, because you can go back and then pull that information. So that's why we've kind of arrived at that point of the filter isn't necessarily a place that is entirely stationary. It isn't, if you don't detect it at the sensory level, then too bad. It is a little bit more flexible. And then once we've decided that we're paying attention to something, we can then choose to respond to it or not. If you hear your name, are you going to listen to the conversation or are you going to ignore it? So that's the idea here. Okay, so that's our sensory memory and the idea of how stuff comes into our awareness, how it starts that process of memory formation. But the next thing I want to discuss is our immediate memory. And this is another concept that has a bunch of different terms that can be used. So I'm using the term immediate memory. I'm actually recently introduced to it because it's a general term that talks about their system that actively holds on to a limited amount of information so that we can do something with it. Usually in texts, you'll see this referred to as either short-term memory or working memory, or some texts are great and just squish them both together. They call it short-term working memory, or STWM, which is awful. But most of the time when you get into the literature and when you start looking at it, short-term and working memory are slightly different. So short-term memory is just dealing with holding on to information, whereas working memory is all about working with or manipulating information. So if you're doing mental math, you're using your working memory. Whereas if you are just holding on to a grocery list in your mind, you're using your short-term memory. And so we're going to use the term immediate memory to refer to both as sort of a general category. So we're saying immediate memory so that we don't have to say short-term / working memory every single time. It's a nice, efficient term that I've discovered, and I really like it. So we can also think of this immediate memory as the contents of our consciousness. So again, back to the chapter on consciousness. We have our conscious, the preconscious, and the unconscious. This is the stuff that is actively in our awareness. It is our conscious mind. It's the stuff that we're currently holding on to. So, all right. And so we can have 3 distinct characteristics of this immediate memory that we can talk about. We can talk about representation. So what kind of information is our memory system using? As I've said, we're going to stick a lot to our visual and auditory stimuli because that's what's most well studied. But we could represent information in different ways, and we'll get into that a little bit more in the working memory specific section. We can also look at duration, so how long a memory system can hold on to that information before we forget it. And then capacity is how much information can we hold on to at any given time. And so we're going to talk about each of these in their own little sections. All right, so for representation first, as I said, we're going to talk about auditory and visual stimuli. And we're basically talking about what kind of information are we representing, or how is this information coded in our minds. So the first is our auditory information, so our inner voice. So maybe if your mother gives you a list of groceries to pick up when you're at the store, you would repeat that list in your mind. So you would have to go and get bread and milk and cheese. So you would hear those words in your mind's eye, or mind's ear, I guess. We can also look at visual information, so maybe your inner eye. So instead of the words, you are looking at visuals of those things. Maybe you're imagining a basket that has a loaf of bread and a gallon of milk and a chunk of cheese. That might be how you're storing that information. So we have different ways that we can represent information depending on what we're doing with it and how it was given to us in the first place. Next is our concept of duration. So how long do we hold this information in our memory? And of course, it's going to depend. So we can start seeing a decline in our ability to recall information as quickly as 3 seconds after we receive it. And we can hold on to some information for up to about 20 seconds, but after that, it's mostly going to be lost. And so if we look at this diagram here, this was people being presented with a bunch of letters and asked, which letters do you remember seeing? And so after 3 seconds, we still have a pretty good percentage of recall. They were correct on most of them, but we see a pretty quick drop off. And once we pass that 18-second mark, so sort of 20 seconds and onward, there's effectively no accurate recall. And so we could call this a forgetting curve, sort of how quickly that information leaves our memory. So our immediate memory can't hold on to things indefinitely. Now you might be thinking that what if we do something like repeat that list over and over in our heads? That is a process called rehearsal. And with rehearsal, we can effectively hold stuff in our short-term memory indefinitely. So we can repeat these over and over again and hold it there in order to keep it forever. But when we're looking at sort of that forgetting curve, we're looking at what happens if we are prevented from rehearsing that information. So if we were, I guess if we have 20 seconds to kill, maybe they get you to do a math question. Or they'd show you an image or ask you to do a task, something that would prevent you from having the free mental energy to rehearse those terms. So they can distract you long enough to make sure that you haven't rehearsed. And that's how we see those drop-offs in responding. And we can actually sort of extend the duration that we can hold on to information. So rehearsal is sort of an indefinite extension. We also have different kinds of rehearsal. And as we are going to find with memory, the more connections you can make, the more extra information you can bring in, the better you are at remembering things. So what we've talked about, just repeating the list over and over again, would just be simple maintenance rehearsal. So you repeat the list as is over and over. If you wanted to be a little bit more certain that you're going to hold on to it, you might use elaborative rehearsal. So instead of just repeating, bring in some extra information. So maybe you're thinking of, okay, well, bread to make sandwiches, and milk to drink with sandwiches, and cheese to go on those sandwiches. That's how you're going to remember it. And by adding extra information, it actually makes it easier to remember, not harder, which is kind of cool. And the last thing I wanted to cover is capacity. So this is how much information we can hold in our memory at any one time. And so there's a lot of debate on capacity. So typically you can get people to agree that it's about what you can rehearse in 2 seconds. If you had to go any longer than 2 seconds, you start forgetting things, as we saw with our forgetting curve. But if it's something that you can go over in about 2 seconds, you can typically hold on to that. And the general rule of thumb is that we have about 7 units of information, plus or minus 2. So some people could hold on to, say, as many as 9 distinct items or letters or whatever. And some of us are a lot less effective and could only hold on to, say, 5. And when we start looking at case studies, there are some people who can have as short of a memory span as, say, 2 items. So there's a lot of variability here. But we could actually call that a memory span, which is the number of items that we can hold in our memory at any one time. And if we're specifically looking at, say, numbers, we could call that a digit span. And that's just a very common memory test, especially in case studies. So we'll come back to those later. But of course, so if we've talked about capacity, we can also talk about extending capacity. How do we remember more than just that 7 plus or minus 2? And one of the best practices to do this is to use a process called chunking. And this is basically where you start grouping familiar stimuli in order to store them as a single unit. So our first line here is a bunch of letters, and they're clustered into 4s. And we could look at that, and that is 5 clusters of 4. That's 20 separate letters. I am not remembering 20 letters, especially not while I'm lecturing. But the last 4 is the word best. That's just one thing I would have to remember. I could remember that for a couple of seconds if I needed to, if I'm holding it in the back of my mind. But the rest of it, gone. However, if we group them instead of into sets of 4, what if we grouped them into actual words? At the bottom there, we have 4 distinct words. Still 20 letters, but only 4 words. That's a lot easier to remember. We've chunked them or collected them into some kind of meaningful unit, and now instead of remembering 20 individual letters, we're only remembering 4 words. So that's a lot easier. And this works for things like phone numbers. So if you think of an area code, it's technically 3 numbers, but you treat it as sort of one unit. So if you're in Edmonton, you have a 780 or a 5, whatever the other one is. I'm also really bad at numbers, so that's probably a terrible example. But yeah, we can sort of cluster them together into some kind of meaning. And so it allows us to just hold on to more things by effectively reducing them to an idea, sort of grouping them together like that. All right, and remarkably, that was what I wanted to cover. So the next topic we're going to hit is specifically into working memory. And we're going to look at the differences between working and short-term memory, so actually manipulating information instead of just holding it. But like I said, that's what I wanted to cover this week. So even though it was a little bit quick, it means that we don't have to come in on Friday. So what I'm going to do is I'm going to use Friday to grade our midterms so that I can have those marks up on Moodle as quickly as possible. And then you guys get an extra day off, and then we come back after reading week and we'll pick up on the rest of memory. So we should have tons of time. We're quite a bit ahead of schedule, so it should be really good. But yeah, I'm going to make an announcement to make sure that you know not to come in on Friday, also so that maybe I remember not to come in on Friday. But that'll be up soon.